Hey, welcome back to Fast Track AI, your pit stop for the hottest breakthroughs in artificial intelligence, served fast, direct, and always a little wild. Today we're unpacking 5 papers that, together, hint at nothing less than an AI-accelerated scientific revolution. Grab a coffee, strap in, and let's roll. First we cover ReflectEvo, metacognition as a training signal. The paper. ReflectEvo, improving meta-introspection of small LLMs by learning self-reflection. Why it matters. ReflectEvo shows that even small language models can bootstrap better reasoning without teacher models or human labels. How it works. First, the generator produces an initial answer and chain of thought. Then the reflector, same base model, critiques that answer, locating errors and suggesting fixes. Finally, they run this process over and over to generate a huge training set, about 460,000 question-answer reflection examples across 10 different domains. Then they fine-tune the model in 2 steps. First with supervised learning to teach it the basics, and then with preference tuning to help it pick better answers, even using reflections that aren't perfect, so it learns to judge quality. Quick definitions. 1. SFT, supervised fine-tuning. The model is trained on labeled data, in ReflectEvo's case, question, answer, and reflection triples. This teaches the model what to do, generate answers or self-critiques. In Think or Not, SFT is done with thought dropout, where some chains of thought are randomly blanked out. This teaches the model that sometimes it should give answers without reasoning. 2. DPO, direct preference optimization. After SFT, the model is shown pairs of answers, like A, thoughtful but clunky, B, clean, confident, maybe terse, and it's trained to prefer the better one, not by computing rewards, but by directly optimizing toward the preferred choice. This avoids the instability of full-on RLHF. Key numbers in the study: Llama 3.8b jumps from 52.4% to 71.2% average score on Big Bench, and Mistral 7b jumps from 44% to 71%. No external teacher, only self-generated reflections. The takeaway reflection isn't just a nice user experience, it's a usable training signal that scales. Next we cover Think or Not, selective reasoning, human style. The paper, Think or Not, selective reasoning via RL for vision language models. The problem, GRPO-style RL makes models always dump a full chain of thought, great accuracy, awful latency. Quick definition, GRPO, generalized repetition penalized optimization, is a reinforcement learning method that trains models to give detailed, high-quality answers, often with full chain of thought reasoning, but also penalizes excessive repetition or unnecessary verbosity, hence repetition penalized. In the context of Think or Not, it means the model is trained using RL in a way that tends to always produce a full chain of thought, because that's what gets rewarded under that style of training, leading to great accuracy, but also bloated, inefficient outputs. The whole point of Think or Not is to break free from this, letting the model learn when not to think out loud. The solution. Think or Not trains a model to skip reasoning when the question is trivial. Stage 1. Thought dropout. SFT. Randomly blank out reasoning traces so the model learns answer only is allowed. Stage 2. GRPO with skip reward. Reward equals task accuracy minus reasoning cost. In other words, the model gets trained to weigh whether it's worth thinking out loud. If it can answer correctly using fewer tokens, it earns a higher reward. This teaches it not just to be right, but to be efficient, mimicking how humans sometimes skip detailed reasoning when it's not needed. The results: Clever counting, Clever, compositional language and elementary visual reasoning, a benchmark for testing visual logic in AI. In this task, Think or Not reduced reasoning output length by 87% without losing any accuracy, teaching the model to skip unnecessary steps and stay sharp. GOQA geometry. GOQA, geometric question answering, a benchmark designed to test spatial and mathematical reasoning in AI. In this case, Think or Not shortened its reasoning output by 65%, while actually increasing accuracy by 17%, a phenomenon often called the free lunch effect, where efficiency gains come without trade-offs, up to 90% token savings overall. Why we care? Pair ReflectEvo's deep thinking with Ton's skip button, and you get smart and fast. Segment 3, SynEVO. Plus, NOVELSEEK, AI as autonomous scientists. 3A, SynEVO, neuro-inspired cross-domain evolution. The paper, SynEVO, a neuro-inspired spatio-temporal evolutional framework for cross-domain adaptation. Think of it like training an AI the way you'd train a student. First, it gets a curriculum, a smart ordering of tasks, from simple to hard, like a class syllabus. Then it develops 3 core abilities. The elastic common container stores useful knowledge that applies across subjects, like general rules or patterns. This is its cross-domain memory. The task-independent extractor looks at each new subject and figures out what parts of that stored knowledge are actually useful, matching the right tools to the task. The adaptive dynamic coupler steps back and sees the big picture. It decides when the model's worldview needs updating, like revising its mental model when new data challenges old assumptions. In short, 1 part remembers, 1 part matches, and 1 part updates the worldview. Wins. The model trained using SynEVO performed 42% better at generalizing to new, previously unseen data in a specific test environment, urban sensor datasets. In AI, generalization means doing well not just on the training data, but on new, unfamiliar data. That's a big deal. At the same time, it used 78% less memory compared to the old-school way of training 1 model per task. That means this approach is not only smarter, it's lighter and more efficient too. Imagine replacing 5 clunky robots with 1 agile multitasker who remembers everything and still runs faster. That's a potential game changer, and it might even hint at how far we can push modularity in AGI. If one system can generalize this well across domains, maybe truly general intelligence won't need as many separate pieces as I once thought. 3B, NOVELSEEK, Closed-Loop Multi-Agent Lab. The paper, NOVELSEEK, when agent becomes the scientist, building a closed-loop system from hypothesis to verification. The pipeline is an idea innovation agent into a self-evolving hypotheses, scored by an assessment agent with optional human feedback. The method has the dev agent convert the idea into runnable code. Next, the experimental planner takes a broad scientific idea and breaks it down into smaller, manageable tasks, just like how a scientist might divide a study into experiments or steps. Finally, the coding agent. Once those steps are defined, this agent writes the actual code for those experiments. If there are bugs, errors, or things that don't run properly, it automatically fixes them until the entire code repository, repo, works as intended. The results feed back for next iteration. These agents automate what would normally require a whole team of researchers and coders. The AI not only plans the experiment, but also writes and fixes the code to run it, pushing us closer to AI-led science that doesn't need much, or any, human intervention. The benchmarks. First reaction yield prediction. The AI improved its ability to predict the success rate of chemical reactions from 27.6% to 35.4% in just 12 hours of autonomous work. An enhancer activity prediction, ROC. It went from a score of 0.52 to 0.79 in 4 hours. ROC is a metric from 0 to 1, where higher means better accuracy in identifying biological patterns. This is a major leap, showing solid predictive skill. Finally, we look at 3D semantic segmentation. It improved from 78.8 to 81 MIOU in 30 hours. MIOU, mean intersection over union, is used to measure how accurately the AI can label different regions in 3D images, useful for fields like robotics or medical imaging. These aren't toy examples. This is real scientific work across very different domains, getting noticeably better in short time windows without human intervention. SynEVO gives us a brain that grows. NOVELSEEK gives us a lab that runs itself. Finally, advancing the scientific method with LLMs. The perspective. Advancing the scientific method with large language models. From hypothesis to discovery. The big picture. Large language models, LLMs, already support researchers in common areas like reading and summarizing papers, lit review, designing experiments, and analyzing data. But this paper argues the next phase is something much bigger. Deep integration, where LLMs become active, generative collaborators, proposing entirely new, testable scientific theories on their own. It also points out some major roadblocks: hallucination. Can we trust the ideas AI makes up? Bias and transparency. How do we audit and understand why the AI made a decision? Intellectual property. Who owns an AI-discovered cure? If you ask me, they should be common human intellectual property. Autonomy. How far should we let AI go before a human steps in? Well, probably not to paperclips, but since we are already in a profit-maxing apocalypse, the point may be moot. To deal with these, the paper recommends hybrid loops, pairing LLMs with symbolic logic systems, robotic labs that do the real-world experiments, and humans to handle values, goals, and ethics. What's striking is how much the papers we've covered already address this vision. ReflectEvo and Think or Not work toward models that can self-correct and reason efficiently, foundations for trustworthy autonomous AI. SynEVO shows how to scale across domains with a shared memory and reasoning system. NOVELSEEK closes the full loop from idea to experiment to improvement, exactly the kind of deep integration this paper is calling for. So we're not just imagining this future, it's starting to happen. Why Include It gives philosophical scaffolding, so ReflectEvo, Think or Not, SynEVO, and NOVELSEEK aren't isolated hacks. They're puzzle pieces toward automated, trustworthy science. Conclusion: the real endgame. Metacognitive boosts, ReflectEvo, cognitive thrift, Think or Not, cross-domain plasticity, SynEVO, and self-running labs, NOVELSEEK, converge on the vision sketched in advancing the scientific method. The real breakthrough is AI that invents new physics, discovers new medicine, and finds ways to keep Earth livable. That's the trajectory we're on, and it's starting to feel less like sci-fi and more like a near-future roadmap. Smash that like, subscribe if you want to stay future-proof, and hit the bell so you don't miss a single breakthrough. Until next time, keep your learning rate high and your loss low. This is Fast Track AI, signing off.